3 minutes ago, the silence of the cosmos broke. A new object, C 2025 V1 Borisov, was discovered drifting between Earth and the enigmatic interstellar comet 3I Atlas. Both objects now shine in our skies, bizarrely bright but nearly tailless, defying cometary physics and leaving experts stunned. Is this the start of a cosmic collision, a rare celestial alignment, or something no one yet understands? Here is what no telescope has revealed. Yet. Discovery. On the night of November 2nd, 2025, a faint, unfamiliar blur appeared in images captured at the Margot Observatory in Crimea. Gennady Borisov, the astronomer at the telescope, watched as the object moved against the fixed stars, its path just off the familiar tracks of main belt asteroids. Within hours, Borisov reported the observation to the Central Bureau for Astronomical Telegrams, attaching precise coordinates and a first estimate of brightness, magnitude 12.1, a diffuse coma nearly half a minute across, and no sign of a tail. The object was provisionally tagged as JEEB 0000810, a code that signaled to the global astronomical network that something unusual had entered the field. Borisov. The name carries weight in these circles. In 2019, he built and used his own telescope to spot 2I Borisov, the first confirmed interstellar comet, earning a place in astronomical history. Now, 6 years later, his sharp eye and homemade optics had caught another outlier. Alert! As word spread, observatories from Russia, Japan, Ukraine, and the Canary Islands raced to confirm the find. Digital images and brightness estimates poured into online forums and official databases. Most teams saw the same thing Borisov did: a condensed, bright coma, but no tail. Only 2 out of 10 early reports hinted at a faint, inconsistent tail, details that would fuel debate in the days ahead. Name. By November 3rd, the discovery was posted to the global confirmation lists. The Central Bureau issued an alert, and the provisional tag quickly gave way to an official name, C 2025 V1 Borisov. With the designation came a call for urgent follow-up. Amateur and professional astronomers were urged to gather photometry, astrometry, and any possible spectra to pin down the orbit and nature of this newcomer. International. The pace was relentless. Each hour brought new images, fresh measurements, and more questions. Borisov's find had shifted from a lone alert to an international campaign. The world's telescopes now turning to track the path of C 2025 V1 Borisov as it crossed the sky between Earth and the strange interstellar visitor. 3I Atlas. Earliest traces. Palomar. Observatory's survey frames from October 29th revealed the earliest traces of C 2025 V1 Borisov, a faint smudge at magnitude 17.5. Within 5 days, the object brightened by more than 5 magnitudes, nearly a 100-fold increase in visible light. That rapid surge set off a chain reaction among amateur astronomers worldwide. Confirmation images. By November 3rd, images from Sukagawa in Japan, Lviv in Ukraine, and the Astrovert Astrofarm in Russia appeared in online forums, each confirming a condensed, sharply defined coma. Still no tail. La Palma's stack from November 4th measured the coma at 4.6 arcminutes across and a magnitude of 10.9, pushing the object into the reach of modest backyard telescopes. Nightly exchange. The real-time exchange of data became a nightly ritual. Observers posted raw images, photometric measurements, and visual estimates to Cloudy Nights, COBS, and Telegram groups, cross-checking results across continents. In Ageo, Japan, a local team logged the object at magnitude 12.2 on November 2nd, while a Ukrainian group in Lviv independently measured 12.1 just hours later. By early November, the consensus held. The new comet was brightening faster than expected, visible to amateur setups under dark skies, and its coma dominated every image. Outlier reports. Reports poured in from Siding Spring in Australia, the Cherenkov site at La Palma, and smaller stations from Poland to South Africa. each confirming the object's position and brightness with minor variations. Most teams agreed on the lack of a tail, but two reports, one from Crimea and another from Japan, hinted at a faint extension, inconsistent in length and direction. Those outlier sightings sparked debate, with some attributing the effect to image processing artifacts or background stars. The majority of stacked images and visual sketches reinforced the prevailing view: a bright, round coma, no obvious tail, and a magnitude curve that defied initial predictions. Global response. The pace and breadth of this response underscored the power of global amateur networks. In less than a week, the discovery had been independently confirmed from nearly every longitude, each team contributing to a composite timeline of the comet's rise. The community's collective effort provided not just verification, but a detailed magnitude history and a living record of the object's changing face. With the brightness surge confirmed and the coma-only morphology holding across sites, the next challenge loomed: pinning down the orbit and understanding the geometry that placed C 2025 V1 in such an unusual position between 3I, Atlas, and Earth. In the pre-dawn hours of November 7, 2025, three comets trace separate arcs through the inner solar system: C 2025 V1 Borisov, 3I Atlas, and C 2025 K1 Atlas, each following its own orbital plane. The SkyLive's orrery models reveal a geometry that defies the simplicity of a flat sky map. While V1 Borisov and 3I Atlas appear clustered in Virgo from Earth's perspective, the reality is a spatial gulf measured in tens of millions of kilometers. C 2025. V1 Borisov is the closest to Earth at roughly 0.55 astronomical units, crossing upward from below the ecliptic. Its path brings it nearly between our planet and the outbound 3I Atlas, which stays well above the ecliptic on a hyperbolic escape. The two comets never come close in space. On November 7, their projected separation on the sky ranges from 44 to 51 degrees, depending on the observer's longitude. For comparison, that is about the width of two outstretched hands held at arm's length. 3. Atlas, with its hyperbolic trajectory, remains physically distant, about 1.8 astronomical units from Earth at its closest, and always far outside the orbit of Mars. Its apparent alignment with V1 Borisov is a quirk of viewing angle, not a sign of real proximity. Observatories in both hemispheres, Mauna Kea, Cerro Paranal, La Palma, Siding Spring, report similar angular gaps, confirming the illusion holds worldwide. Meanwhile, C 2025 K1, Atlas travels a wholly different course. Its orbit, inclined steeply to the ecliptic, keeps it in Leo, separated from the other two by more than 14 degrees on the sky and even farther in three-dimensional space. On November 7, K1 Atlas's heliocentric position matches V1 Borisov's in distance from the Sun, but the two are nowhere near each other in the sky. This geometry creates a brief window, November 6 to 8, where all three comets are visible before sunrise, each occupying a unique slice of the celestial sphere. The alignment is only visual. The true separation between V1 Borisov and 3I Atlas is vast, with K1 Atlas even more remote. For observers, the orrery's three-dimensional perspective is the only way to grasp the scale. Three objects, three distinct orbits, and a fleeting alignment that exists only in the mind's eye, not in space. Virgo dominates the southeastern sky before dawn in early November, offering a rare stage for comet watchers. C 2025. V1 Borisov appears here first, rising well ahead of the Sun and holding steady at magnitude 13, within reach of backyard telescopes under dark skies. To spot it, start scanning Virgo about 2 hours before sunrise. The comet sits near the celestial equator, making it accessible from both hemispheres. Even small telescopes, 8 inches or larger, can pick up the condensed coma as a soft, round glow. On clear mornings, observers have reported seeing the coma grow in size and brightness, but most still find no sign of a tail. Tateless, just a few degrees to the west, 3. Atlas tracks a similar path through Virgo. It is slightly brighter, hovering around magnitude 10, but its appearance remains stubbornly tailless despite the increased solar activity of recent days. Both comets are best viewed in the final hour before twilight, when the sky is darkest and the objects are highest above the horizon. Star charts and digital planetarium apps now show 3I Atlas and V1 Borisov as a close pair, though their true separation spans tens of millions of kilometers. Golden yellow. Meanwhile, see 2025 K1. Atlas stands apart in Leo, east of the other two. Its golden yellow tail, unusual among comets this season, makes it a favorite for long exposure photography. K1 is fainter, around magnitude 14, but its color stands out against the background stars. The best chance to catch K1 is also before dawn, with Leo climbing higher as the night progresses. For those tracking all three, this brief alignment window, from November 6th to 8th, offers a unique observing challenge. Binoculars may reveal the brightest comet, but telescopes will show the subtle differences in brightness and structure. The sky map changes nightly, so fresh coordinates from online ephemeris tools help keep the search precise. With each clear morning, observers join a global campaign, gathering new data and watching for any sign of change in these mysterious visitors. Unexpected. A bright coma without a clear tail is not what most observers expect from a comet surging toward perihelion. Yet both C2025 V1 Borisov and 3I Atlas have defied the textbook image. Their comae shine sharply, while tails remain elusive or absent. Dust physicists turn to the behavior of grains under sunlight to explain this puzzle. The key lies in the radiation pressure parameter beta, which measures how strongly sunlight pushes on dust. For grains larger than a few microns, beta drops below 1. These heavier particles do not get swept away from the nucleus. They linger close, thickening the coma but failing to stretch into a classic tail. Heavy grains. In V1 Borisov, most ejected grains appear to be large and refractory, with beta values less than 1. The solar wind and sunlight simply cannot push them far from the nucleus before they slow and settle. 3I Atlas II shows a coma dominated by similar grains, likely a mix of icy and carbon-rich material, but again with a bias toward the heavy end of the spectrum. The result is a dense, compact cloud of dust, bright in all directions but lacking the extended streamer that marks most active comets. Viewing geometry. During early November, both comets sit at high phase angles, where forward scattering by dust grains amplifies the brightness of the coma as seen from Earth. This optical effect can make the head of the comet appear even brighter, while any faint tail is drowned out by glare. The combined result is a striking, coma-only apparition that challenges both visual observers and the models they rely on. High-resolution images are now in demand, as astronomers look to resolve whether any fine tail structure is simply hidden by the physics of dust and light. Persistent brightness. 3I Atlas continues to defy expectations, not just in appearance, but in its measured brightness. Visual estimates and photometric data from early November place the comet at magnitude 9.8, substantially brighter than the 11.2 predicted by standard light curve models. This 1.4 magnitude gap means 3I is nearly 4 times brighter than expected, a discrepancy that has drawn the attention of dynamicists and comet modelers alike. The anomaly is not explained by a sudden surge in activity or a visible outburst. Instead, the comet's coma remains compact and sharply defined, with no significant tail and only minor changes in the surface brightness profile. Orbital solutions from JPL and ESA have incorporated updated astrometry, searching for evidence of non-gravitational acceleration, tiny pushes from outgassing that can nudge a comet's trajectory. So far, the calculated non-gravitational term for 3I. Atlas is small and hovers near the threshold of significance. Both agencies report only marginal deviations from a purely gravitational path, with disagreements focused more on the statistical noise than on any clear physical effect. This is a marked contrast to 1I Oumuamua, which showed a measurable non-gravitational acceleration and fueled years of debate. Composition clues have fueled speculation about the comet's makeup. Spectroscopic hints point to a mix of less volatile, more refractory materials, possibly enriched in carbon. These components could explain the weak outgassing, the dense coma, and the stubborn absence of a classic dust tail. For now, the numbers raise as many questions as they answer. High-resolution imagery from space-based telescopes is urgently needed to resolve the structure of the coma and confirm whether subtle features are being masked by the limits of ground-based observations. Until then, the photometric anomaly of 3I Atlas stands as one of the most intriguing puzzles in the current observing campaign. China's Tianwen probe, orbiting Mars, quietly released its first look at C 2025 V1 Borisov in early November, a short, low-resolution video clip captured weeks earlier. The clip confirmed a bright coma but offered little detail about the nucleus and no clear hint of a tail. The anticipation among astronomers had built steadily. Many hoped for a clear view of the comet's structure from a unique vantage point. Instead, the public received a brief, grainy sequence that left key questions unanswered. The delay in release, attributed to internal review and press coordination within CNSA, left the international community waiting longer than expected and underscored the challenge of relying on major space agencies for rapid data sharing. Hopes now turn to NASA's Mars Reconnaissance Orbiter and its HiRISE camera. As of November 7th, no images of Borisov or 3I Atlas have been released or confirmed as pending. Scientists at JPL cite the need for optimal geometry and internal review of the imaging plan, but the lack of updates has put the community in a holding pattern. The debate is not about censorship, it is the slow churn of mission priorities and technical limitations which often push comet imaging to the back of the queue. Meanwhile, calls for high-resolution images from the Hubble and James Webb Space Telescopes grow louder. Multiple target of opportunity proposals have been submitted, each vying for precious observation time to resolve the coma and settle the tail question. As of this week, none of those proposals have been approved or scheduled, and no new space-based images have entered the public domain. The result is a bottleneck. Amateur and ground-based images can only go so far, and answers to key questions about Borisov and 3I Atlas remain just out of reach, locked behind institutional review and the slow pace of data release. The story of these comets now hinges as much on who controls the data as on the objects themselves. Solar storms have swept across the inner solar system in recent days, with geomagnetic indices spiking and auroral displays reported from North America to Siberia. These storms offer a natural experiment. Strong solar wind and increased ultraviolet radiation should trigger outbursts or at least enhance tail formation in comets passing near the Sun. Yet, for both C 2025 V1 Borisov and 3I Atlas, observers have found no major changes, no sudden tail, no dramatic shift in coma structure. The lack of response is striking. As the storms continue, astronomers are watching for any sign of delayed activity, urging the community to keep monitoring both comets during these heightened space weather events. Speculation has grown about a dispatch from 3I Atlas. The idea has gained traction online, but it remains firmly in the realm of what if. Predictions. Clear, testable predictions to watch include sudden changes in the trajectory of C 2025 V1, unexpected bursts of non-gravitational acceleration, a fragmentation event that does not match cometary physics, abrupt shifts in brightness, unexplained radio signals, or coordinated changes in both V1 and 3. None of these have been observed so far. Current data show a stable orbit and coma. If any such anomaly appears, it will stand out in the daily logs and coordinate updates. Until then, the best approach is to track the predictions, compare them to real-time data, and let the evidence decide. Tonight, two bright, tailless mysteries cross above our horizon, while data gaps and physical anomalies persist. As solar storms rage and telescopes await sharper views, the unexplained brightness of 3I Atlas and Borisov forces astronomers to rethink comet physics in real time. The cosmos is not done surprising us. For now, every unanswered question is a reminder. Discovery is no longer rare, it is relentless.